Hello everyone, good afternoon. My name is Abdulraheem Adebayo. I'm going to be presenting today on the topic calculus, introduction to calculus, the origins and the impact of calculus. I know that just like myself, a lot of students that study mathematics, they have a hard time understanding the use of all of these things we study in school in their day-to-day lives. So I'm hoping that this my short presentation is going to give you a bit more insight about the use of calculus in our day-to-day lives. First of all, the historical background of calculus. Calculus emerged in the late 1600s through an independent work of Isaac Newton and Gottfried Leibniz. Newton applied it to physics and motion, while Leibniz developed a more formal notion. Earlier thinkers like Archimedes and Bhaskara too explored foundational ideas, but it was Newton and Leibniz who formalized calculus. This marked a revolution in mathematical thought and enabled advance across science and engineering. So why do we need calculus? Calculus is needed in our day-to-day lives because algebra and geometry fall short when modeling phenomena like instantaneous velocity or growth over time. Calculus fills this gap. It tackles problems of change through differentiation and accumulation through integration. At its core, calculus is the study of continuous change, which is essential for understanding natural and man-made systems. The basic concepts of calculus. We have two basic concepts in calculus. These are derivative and integration. For derivative, it measures how a function changes based on its input. So it tells us how a function changes like speed or slope. For integration, it measures accumulation such as an area under a curve or total distance. Derivatives are written as f prime of x or df dx. Integrals are written with the integral sign followed by the function dx. So the next time you see this, you know these are basic concepts of calculus. So a quick example, let's take the basic function f of x equals x square. The derivative of this function is going to be 2x. So what this means is that when x is at 3, the slope is 6. This means when you draw out a graph of this function, as you are as you this the graph tends to get steeper at this point. Is a clear example of how derivative is used to describe change. So let's go into real world applications. Calculus is used everywhere. In physics, it is used to describe motion and forces. Engineers use it to design everything from bridges to electronics. Economists model supply and demand curves with it. Biologists apply it to population models. Even everyday tools like GPS or medical images rely on calculus behind the scenes. So let's give you some real world examples to give you more insight. I know a lot of you might not solve calculus every day, but calculus is actually behind most of the everyday tools and systems that we make use of. For example, I'm sure a lot of us have used our maps or GPS today. Calculus is used to calculate the shortest path on these maps. They optimize our travel time and predict the traffic flow. So the next time you are opening your maps, you remember that you are now applying what you learnt in class in the real world. Let's take another example. Online shopping, for example. Companies use machine learning algorithms based on calculus to analyze data and suggest more products for you. They are also used for data trends to show patterns over time and medical imaging. Thank you guys for your time. This is my presentation.